Let's continue our course. Let's add another rafter between these two boards. Select them using Control on the second floor plan. Go to. The distance here is just 835 is too much. Let's add it. It won't make things worse. Copy these two boards. Select them using Control. First these two boards, then like this. Copy arbitrarily. Now let's remember in the filters we turned off the ridge. Let's return it. So we can see it. This dimension can be deleted. This dimension was selected to edit the dimension chain. Let's set it like this from this board to the middle of this one to this board. Let's press. If this happens, try lowering the cutting plane a little. Set 2.200 and then try to catch it. Now it snaps to the middle line of the board. Everything is fine, that is, this moment. Let's immediately mirror these two boards to the other side. We've done that. We'll remove this extra board. Switch to the 3D view. Shorten the rafter leg. And now we'll build a lintel here and attach it to this board, so that we can work comfortably directly in the 3D view. Before you build a board like this on some inclined plane, you first need to designate the plane as working in the program. Click Architecture, Set, select the working plane. Select the plane, let's say the edge of this board. Select the board, create an analog and build arbitrarily. Do not forget that if you want it to be built orthogonally to the horizontal plane in the 3D view, hold down Shift. You have this snapping caught at 90 degrees, very convenient. We first build arbitrarily. Here our board is built. Sometimes it happens that it flies off in the wrong place. Look. Not that it flies off, in the properties it can have alignment along the z-axis. Now it is on the top, which means it is aligned with our plane on the top edge. Or it can be on the bottom, then it will be like this. Just change it then no. You don't need to try to move it, just change this alignment along the z-axis property. Press up, so we immediately cancel the adjacency. Do not forget at both ends. The construction brand, don't forget to put the one. We need the rafter system. We'll shorten it. Let's extend it here, so let's go to the section view. Move the section here. Go to it. Here is our lintel. Let's move it a little. The move command. Do that and extend the board to it. Here let's filter by, so that we can see the current stage, so that our entire architecture is gone. Let's extend. That's it. Go to the 3D view. Great. Now let's go back to the section view. We found the boards along this axis and trimmed them. Cut board, axis, board, axis. That's it, we're done. Leave it like that. Next, so our cup is hanging in the air. Let's open it. Select the element, hide the element. Or you could hide it through the context menu. I wanted to make eaves overhangs, but let's talk about fasteners today. First, let's connect our Morlad to our wall with the connect command. We'll connect here too. You can connect the beams with the connect command so that this separation line disappears. If necessary, let's do that for now. They remain separate elements. They will be specified separately. This separation line simply disappears. Let's leave it that way for now. Next, let's check the model intersections. Frame. Load-bearing frame load-bearing. Press OK. Something's wrong. Let's escape. Press escape. We didn't have anything selected. Run the intersection check again. Frame load-bearing frame load-bearing. OK. There's an intersection. Be careful, don't close this window. The cut board. Board. Update commands. Let's move on. Yeah, you can also use the connect commands to quickly make these cuts on all. The rafters, look, you can select connect, multiple connection. Select our Morlad like this, select the frame. So that this rafter leg falls into this frame, well, all the beams that interact with this beam, it will connect with it. That is, these cuts are immediately formed. That is, last time remember. We cut out each rafter leg. This is, of course, more accurate, but in principle, you can try. Select the rafters, use the connect multiple connection command. Select the rafters, and simply select all the rafters. All these cutouts will be created. Well, I don't know, I'm used to carefully cutting through each beam, cutting. It's not that long, but I'm sure everything is precise. You do it the way you prefer. Cut. Cut the second one. Cut the second rafter out too. Here, too. Cut again. You can click Execute Check. Click Show Latest. Report, and then click Refresh. See, everything's gone. We have no more intersections. Let's talk about riveting today. But first, I don't like the very long tails here. Let's make the overlap smaller. Let's go to the auxiliary section. Draw an auxiliary line. Draw a detail line and shorten our board to it. Dot. So, we have this overlap. Well, we can extend this board a little here. We also take a line, copy it, and we can do it here. The extend line command is more accurate. Then, the extend line command, this board. Let's see. This overlap is quite sufficient. We can make it a little bigger. We can take the size 820. Let's make a line like this, board. We're all done. We can measure it in 3D view, and we'll also take a ruler. We insert 820. Then, the trim and extend several elements command. Select this edge, all the rafters, and shorten these ones as well. Well, in principle, we can leave them there. Escape twice, trim and extend several elements again, and on this edge, we extend all the other boards. We've done. The rafters are attached to the trusses here through an angle bracket and are joined together with either nails or studs. We'll now look at the different families, assuming you have them. Of course, no one models nails in structural models. But it can be done. Click, Insert, load the family, and first select the angle bracket. There are several sizes available. Let's take 55 by 70, the most common ones. We'll take this large one, and this small one, too. Yes, you can do everything. Select everything. Click OK. It's just that when there are too many dimensions. It's not really that many dimensions, but when there are too many dimensions, the family can take a long time to load, so it's better to select the ones you need. Well, let's load all the corners. And they were already here. Yes, replace the existing version. Press Architecture. In the 3D view, we work directly. Architecture, Component, select the corner we need, type size. Let's take 70 by 55 with a wall thickness of 2.5, comma. Here in the base is some edge. You can rotate it as you need with the spacebar. Well, the main thing is to place the base. So we can place it on the planer. We'll place it randomly for now. Double escape, turn off the filter. So the red color doesn't get in the way, override the graphic visibility. Filters. Here are the boards longer than 6 meters. Let's turn it off for now. Done. Placed. We can also assign a construction grade to it. Or set some other parameter so we can calculate it later. Let's set a note for now and set the grade to a 70 angle. Just use the angle for now. So the specifications can later calculate all the angles in the project. Align it to the edge of our board. We've done. Next, let's insert, load the family, and add a 100 mm stud. Architecture component. Its board edge can also be the base. We'll place it randomly for now like this. Now let's go to the auxiliary. But we didn't place it there. Let's go to the second floor plan. Find it, and simply move the section here. Go to the section. Select the stud and move it to the middle. Here are the studs. It's better to fasten the beams with studs in a staggered pattern, not along a single line. Let's move. One here and every 100 millimeters, 100 to 130 millimeters. Copy. One 130. 130, 130. Select these two using Control. Move them. Here. Let's add another one. Of course, 4 is enough. Copy. Also 130. Let's place it like that. These two can be moved. Up. Like this. Of course, yes, to make the connection more secure. It's better to fasten two boards in a staggered pattern. Next, let's insert and load the nail family. Open Architecture, Component. It's immediately linked to this board. Clicked, Parametric Family, you can select it. Change the type, the 80th nail, but that's not enough. We'll make 90, only when you do it, change the name. Rename, and guest 3 on. $90, you can copy. Another one, type size, create 80 there. I'm just showing you how to do it. But you already know this, click OK. Well, and of course, you all can also model. Then calculate the specifications. Well, obviously, no one counts the nails down to the last nail, but it can be done. Let's align our studs along the edge of this board. Of course, it would be cool to count the nails, but they are usually bought by weight with a large margin. Well, that's the kind of fasteners that are more or less substantial, expensive, like corners, plates, studs. Some anchors, some brackets. Yes, I always count them in my projects for the client. Nails, of course, not. The same goes for screws. I'll just show you. There's a family, too. They can be used in some nodes, some 3D types of nodes. We'll do it later, by the way, when we're designing. Click, Insert, load the 3.5. X55. Place. And then go to the plan. There are 4 pieces here too. The component. Was made in the 3D view. You can go to the view. Select one screw using the tab. or through the context menu, right-clicking. Select all the visible instances in the view and set a slight offset. From the base for them in the offset from the main model properties. Let's set it at 3 mm here. So we have a stud here. Yeah, fine. Done. Let's add a stud. Copy our corner to the molding, which is on the reinforced belt here. Well, you don't even have to copy it. You can select it, select the corner. Create an analog. Place it, align it here. Switch to the trivide. Here it is placed here. We've done. Let's lengthen this board a little. Move the auxiliary cut line. There we had 820 by 80. Let's move it. Lengthen the board a little. Here. Comma. You can move this stud a little. 130 in fact. You can make it larger, not 130 millimeters between studs, 20 centimeters. Maybe 20 to 30. That's what we'll do. We'll lengthen all the other boards too. Now that we've done it, let's add a connecting plate. The rafters at the ridge are fastened with either a wooden cover plate, which can of course be modeled. I'll probably show you in the next lesson. For educational purposes, we'll make a wooden cover plate. Generally, you can use structural connecting plates. Insert and load. We had one too. Replace the existing version. Click Architecture component. Then, once again, Architecture. Component. Find our plate. Here it is. 210 by 90. Press the spacebar. To rotate it, we're trying. Make it parallel to our ridge beam, or rather, like this. If that doesn't work, you can double-click Escape, Architecture, and select a plane. Select the plane, specifically the edge of the board. Now, once again, Architecture. Component. It still doesn't work, so you just have to we installed it. We won't be adding screws here. Obviously, we've done everything. Added a plate. In addition to the plate, the rafters are fastened together with 4 to 6 nails at the ridge. 2 diagonal nails, and then diagonal nails to the moorlet. All this is specified in P3105 on frame houses, if you haven't taken the course on assembling a load-bearing frame. You can take it. We talk about it there in more detail. That's it, we've added all the fasteners. The only thing I haven't forgotten is this M100 stud. Not M100, or rather, it's an M14 stud. You can find it in the properties. It's a parametric stud, which is incorrect, by the way. Here, there are two here. This is the name 14. Let's rename it M12. That's what it says. That name is already in use. Strange, did we have such a stud? So we loaded it or something. These are already unclear. We don't remember, maybe. We already loaded it, but never mind, that's not the point. You can select it through Control, since that's all. So we select something like the M12 size. Although they will all become M12. This is the length of this pin. Save the project, don't forget. The length of this pin. There's also a parametric pin. Let's add it. Insert it. Load the family. A regular pin. This one. I'll show you the difference now. Let's go to the component architecture. This one is convenient because if you have more than 2 boards. Let's go to the plan. That is, there are 4 boards. It's just that 2 boards are rarely pulled together with pins, usually larger. It directly by these handles. Adjust. Like this, but if you only have 2 boards, these tails remain. You need to edit the family so they are removed. I just made a separate 100mm pin. You can use it. Let's delete it. Let's say you have 1, but we'll use M100. To change the material, or if the nut isn't listed in the material properties, like the stud itself, you can click Edit Family. Nut, Edit Family. Select the nut, change the material. Click OK. Load it into the stud family first. Click OK. You don't have to save it, click No. Then click Replace Existing Version. We do the same with the washer. Edit Family. We change the color by loading it into the stud first. Comma. Replacing it. And now our project is complete. No, we don't save it, we just replace it here. Why didn't the color change? The color hasn't changed because most likely, this material isn't adjusted here in our project. We could have done that right away. I don't remember what it was called there anymore. It was an existing stage, I think. Yes, we go to Management. Material. Look for our material here. The existing stage, and simply change the color. That's it, It'll change. We fiddled around with everything a bit. So, just so you know how to edit this. A family is a whole other topic. There are separate courses on creating families. I think you know all that, too. So, all we have to do is copy our fasteners to all the other rafters. Let's do this first. Select the plate. Go to the second floor plan. Use the copy command. You can turn on the orthogonal axis and quickly copy it to all the rafters like this. We escaped twice. Switched to 3D VIT. Forgot about this. Let's come back later. Select Copy. Copy here. Copy the corners like this. Let's also transfer everything first with Command. Copy. We've done it, and now the one on our wall's wall. We can try to do it faster, but no, faster, no. We could certainly do it with an array. But the distances between the rafters need to be the same. But in general, they should be the same for us. Here 640, 640. 720, not quite the same. Yes. In general, we have 640 everywhere, but there are some. Well, let me show you. Select the corner, tool, array. Specify the quantity along with this, 15 pieces. Let's say, or 20. Here you select the distance between the elements. The ortho mode checkbox, let it be on. Click once the distance by which you want to move the 640. OK here. So, well, you can select these. And move them to our rafters. It seems fine. We delete these extra ones. And move these too. Copy. Add here on this side. Done. Now you can quickly select them from left to right with a frame. Look in the filter to see if only the corners remain. These are generalized models. Use the mirror tool to create an axis through the middle axis. Simply mirror it to the other side. Let's see if we disabled visibility on the filter. This mower is our architectural model. Yes, we made it with a ceiling. It can be deleted. We already attached our corners to them. No, I apologize, friends. I just pinned this element. I changed the pinning. Delete it, and now I'm returning it through our mower's filters. The one we made with the beam tool. Is great. We can also quickly copy the studs. Select them with Ctrl and copy. We just copy them. Then, when we make the supporting wall, we'll add the fasteners there. We're all done. Let's check the model intersections. You know, like a load-bearing frame, a load-bearing frame. Generalized models, that is, are there any intersections? Collisions between our fasteners and ours, with our lumber. Most likely there will be a lot. Well, it shows every stud that there is an intersection. You can of course take the connect command, select the stud, select the board. All the collisions will disappear, but these are not critical collisions. They do not bother us at all. I am most worried about the corners, so that they do not drown in our boards anywhere. Well, maybe just running through visually seems no. Everything is fine. By the way, here we could have omitted the corners. Because here we have boards adjoining with a clap, a fairly reliable joint. So what is not adjoining here? I don't get it. Oh right, they won't be adjacent there, because here we don't have a single board. They're overlapping here. Well, then we'll leave it like this. The corners in this case are needed here, especially. Comma. Or we can just move them to the other side. Oh no, that won't work. I wanted to just throw them here. But it still won't work. They will then conflict with this board. That's it, no big deal. We'll insert it like this. Everything is fine here. Let all these collisions remain behind the studs. No big deal. Click, close. The filter can be restored in principle for a board longer than 6 meters. The only thing you can change the color so that it doesn't match the selection. Which one to put? Let's make it this way. Pale yellow. That's it, we've added the corners here. We've added plates everywhere for the main fasteners. We'll calculate all of this later. We'll probably move on to the eaves in the next lesson. Paint here. The excess. Close all inactive windows, save the project. We haven't labeled the plates, but they're all in the same place. They're all identical. No problem, we'll be able to see them later in the specifications without labeling and calculate everything. That's it, on to the next lesson.